It's time to meet our last new family of functions for the course. This and the trigonometric functions really makes up all of the well-understood families of functions. So we are well on our way to knowing everything there is to know about functions. Our last family for this course is the exponential function. Now, an exponential function is a function where our variable is in the exponent versus a power function where our variable is the base. We write exponential functions only if the base is a positive number and not 1. So again, this number is referred to as the base of the exponential expression. We were already familiar with that term from our first introduction to exponents, but it's worth recalling here. So why do we restrict our base to positive numbers that are not 1? Well, we don't want it to be 0, because then if we take a negative power of 0, we get a fraction with 0 in the denominator, and 0 to the 0 is also undefined. If b is a negative number, then b to the x is undefined when x is a fraction with an even denominator, because then we're taking an even root. And when we're talking about functions, we only want to think about functions whose domain and range lie in the real numbers at this point in our careers. And then if b is 1, b to the x is 1 for any real number. And then if b is 1, well, b to the x is 1 for any value of x. So if b equals 1, this function is very, very boring. It's just the number 1. It's a constant. We don't want those to be a member of the exponential family. So we rule that out for exponentials. So b to the x is only defined and interesting for all real numbers if b follows those rules. It's greater than 0, and it's not 1. Now, that's the basic exponential function. Just like we could with the other kinds of functions that we met, we can compose that function with linear functions. So we can actually have some linear function of x in the exponent, and then we can multiply by a number, and we can add. Base can be a fraction, no rule against that, right? That's between 0 and 1. Notice here, this means negative 1 times positive 4 to the x minus 4 power. Right? That negative sign is not on the base. That's a big part of the reason that we define this notation this way, is so that when we write expressions like that, it means what we want it to mean. So be aware that you might see negative signs, but those negative signs are not part of the base. So exponential functions, that's all that they are. We just recognize them by seeing that the only place we see a variable is in the exponent.